Good morning, good evening, good afternoon. This is Sunila. Thanks a lot for the opportunity, HackerEarth, for this webinar. So first of all, hearty welcome to the session. This session is on artificial intelligence and how can we use TensorFlow to implement artificial intelligence, implementing artificial intelligence applications. The agenda is very simple. I'm going to very quickly give you an introduction to artificial intelligence, its definition, goals, philosophy. Now, there are a lot of competing terms out here: deep learning, cognitive computing, then machine learning, predictive analytics, data mining, text mining. So I'm going to introduce you all to a bunch of terminologies that are prevalent as part of artificial intelligence. Then we'll look at a quick algorithm overview and we'll see what's new coming up there. Then I will also introduce you to TensorFlow. How do we install? What's the framework? What's the architecture? How does it work? And how can I help you kick off with implementing TensorFlow for artificial intelligence? So I'll start the session with a quick quote from one of the philosophers, German philosophers called Immanuel Kant. It says, "Enlightenment is man's emergence from his self-imposed immaturity. And immaturity is the inability to use one's understanding without guidance from another." Now, very clearly, we humans have been, for several years looking at enlightenment. What does it mean to me? How do we all humans arrive there? But now we have very clear the emergence of robots, artificial intelligence, machines coming up, which are able to really help us out and able to do better than us, right? So that's a simple cartoon to explain what this means. And a quick question to all of us is, are machines already there? Did machines already figure out on what this artificial intelligence is all about and what kind of value we can expect from those systems? Now, this is a very interesting view I would like to run you all through. So a lot of experts in the market have spoken quite a lot of things about what artificial intelligence is and then what it could do to us. We are all aware of our machines beating humans of late. Kasparov was beaten to death by an AI system in chess. And we know of many more systems that's happening. You've got autopilot aircrafts going on today where you don't need human intervention at all. So this slide gives you a quick view of what all experts are saying. They are, at the end of the day, all of them are asking us to be careful, right? And we are looking at something called friendly artificial intelligence. We don't want system to operate by themselves and do everything by themselves and we become redundant, right, in the system. So the interesting part is we know that AI's history is nearly 70 years now, and everybody has been working on artificial intelligence, making systems as intelligent as humans. That's what AI means. And if you're working for so many years, then why are we actually worried about AI taking over us? This is a really strange thing, right? So we've been working for making them intelligent on one side, and on the other side we're saying, we're really worried they won't take over us, right? So we've got a few interesting things that I would like all of you to understand and keep in your mind. So the new thing that everybody's talking about is human-aware AI, right? It's also called human interactive AI, artificial intelligence. Now, what this means, we will learn a bit. The word cognitive computing, cognitive analytics is all about this. So what we're saying is we don't like machines to do everything by themselves. We want human intervention, human interaction. And machines take inputs from humans and then take actions. Now, I think all the hard work that our experts have done for the last 50 to 70 years to bring artificial intelligence to a shape, given the infrastructure advancements, that has been on one side in terms of complexity. But what is now that we're talking about, which is human-aware AI, human interactive AI, is another complexity that we have, right? So we are expecting the systems to understand human psyche, take inputs from humans, and then take care of automating whatever. Apparently, this is becoming more complicated than what we thought AI would have been. And we'll speak about what these complexities are and how human interaction is exactly a complex thing in AI. Now, very simply, I'll go to the ground rules, right? So when we talk about artificial intelligence, so let's say we've got systems without AI and systems with AI. This is basically the ground reality. So what do we think programming without AI means? It means we build a program which can answer specific questions, right? And it knows what questions it would get and what answer to give, depending on, let's take an example of business rules driven application. If the question is A, the answer is B. If A has got complexity, then answer is C, kind of a thing, right? And what do we do when we don't have AI? We actually modify our programs when new rules come in. We write the code, and literally we call it hard coding in programming languages. And any changes that come in does change a lot of structure, code, and many more things in the application. And finally, we also know that this modification is not easy because we've coded for a requirement A, and requirement B comes, we don't know what to do. Actually, we know what to do, we have to recode it, right? So let's take the example of what AI is, programming with AI is, right? So we're talking about a computer as against answering specific questions is built to ask generic questions, right? Answer generic questions. So it follows a bunch of rules. It learns from different answers and then tries to give an answer. They're more generic in nature. And it does not ask us to modify any programs or data structures because it starts absorbing all these modifications and independent pieces together. And then it puts structure around it and it starts taking it as an input and gives an output, right? And definitely it's much easier because we don't intervene and we don't code. They're models which run and which do. So this is the ground reality, okay? Now, I'll introduce you to the jargon. So all of us are very curious about what artificial intelligence is. And I know today the crowd is definitely a mixed crowd. A few of you must be knowing what AI is, what ML is, what data mining is, what statistical modeling is, what cognitive computing is, deep learning is. But if you look at it, this screen does throw up quite a lot of jargon under this umbrella. And most of the times, all the jargon that I've marked in red are interchangeably used. So people say machine learning, AI, machine learning, deep learning, AI, cognitive computing, AI, again, are interchangeably used, right? So, but there's a lot of difference between each of these terminologies. And what I would do is, I'll spend the next few minutes to give you, the difference between what a machine learning is, a deep learning is, AI is, and a cognitive computing is. Assuming this is what our focus of the session is, right? So this is pretty simple. We all know machine learning is nothing but we are helping a machine learn by itself by providing data, but as against by coding, right? The more data you provide the machine, the more smarter it gets, the more automation it can help with, right? Very basic, non-textbook definition is what I can give, right? And deep learning is a subset of machine learning, which helps us solve problems which are solved by humans, typically, complex problems, right? Now, AI is, again, a bigger field. This is nothing but a bigger field of science, which focuses on building systems or machines that solve problems solved by humans, human-like problems, right? So it has to be as rational as human or as thinking as human and acting like human, right? Many more things like that. And there's also cognitive computing. So before I speak about cognitive computing, I will show you all a very quick view, which is on my desktop, right? So if I were to draw a Venn diagram of machine learning, deep learning, and artificial intelligence. This is how typically it looks. This is an image I took it from the internet, but it gives a fantastic view of what things are. So artificial intelligence is the bigger universal superset of problems we're looking at, which includes multiple sets of problem intelligences, which I talk about in terms of categorization in a few minutes from now. So machine learning is actually a facilitator to artificial intelligence, or a subfield of artificial intelligence, which helps us solve all the problems that are categorized under AI. And deep learning is again a subset of machine learning, which solves problems for artificial intelligence. So the categories of learning are multiple, but the problems under artificial intelligence are much more deeper. So deep learning is about multi-layered learning. It's a subset of machine learning. So with the advent of deep learning, solving AI-related problems has become much easier for us, right? So that's what it is all about. Now, I've got a very quick mind map view that you can see on my screen, which talks about what are the goals of artificial intelligence, right? So it's very simple. Create machines, computers as intelligent as human, or create expert systems. What do you mean by expert systems is today, running an airplane in autopilot mode. The system that runs the airplane is an expert system, right? So that's an example of one. So definition wise, definitely we're looking at machines that can act, think, and behave like humans and solve problems like humans, right? Now, additionally, what we're looking at AI systems doing is they have to have the knowledge storage and representation to hold all data. What they say is when we talk about solving problems which are typically solved by human, we're talking about a lot of ambiguity and uncertainties, right? So definitely the data that we use to solve the problems is much more complex in terms of structure and not straightforward. So the expectation of an AI system is to have a knowledge storage to start with, understand natural language like text, assessment, analysis, and process the text, right? Which comes in the category of natural language processing. Then ability to reason, right? Reasoning abilities and answer questions and facilitate conclusions. We're not expecting systems to take a decision, but facilitate. And of course, ability to plan, schedule, automate, all the robotic process automation, intelligent automation that's coming up, powered by AI, is all about this. Then they should be able to build self-learning algorithms, right? And robotics and many more. So this table that I'm showing you out here on my screen gives you a very quick one-shot view of the different similarities and difference between machine learning and artificial intelligence, right? So machine learning, both machine learning and AI, they are employed to focus on automating reasoning and decision making. We all know the similarity between machine learning and AI is machine learning need not focus on solving human inspired problem statements or human solvable problems, right? So machine learning can solve and automate multiple tasks, but need not be the human behavior, is what we're saying, right? But artificial intelligence always focuses on human-inspired algorithms, running them and solving for human behavior, similar to human behavior, right? And the relationship between both of them is machine learning is a facilitator and is a subset of AI, right? This is a very quick view. I've got a very small mind map of deep learning. Again, deep learning is a branch of AI, that being by virtue branch of machine learning, right? Again, it's all the algorithms that are listed in this mind map are deep algorithms. The word deep in simple non-algorithmic definition is solving a problem in multi-layered approach, right? So that's what it's all about. We'll talk about a few of the algorithms which come into this. So I'm getting back to my PPT. So now we've very quickly seen the terms machine learning, deep learning, and artificial intelligence. right? And the new baby in the market, the new term in the market is cognitive computing. Now again, cognitive computing is used interchangeably with artificial intelligence. And the main difference between an AI system and a cognitive computing system is, let's take the example of doctors, right? So an AI system would tell a doctor what to do when a cause for a disease is given. It exactly tells you this exactly is a problem, so the solution for this is A, right? So doctors do take a decision and then move ahead. The AI system is capable of taking a decision and moving ahead. The difference between cognitive computing and AI is cognitive computing includes consideration of uncertainties and ambiguities. Like we humans, when we rationalize, if we're solving a problem A, in the context of X, solution is A1. In the context of Y, the solution is A2. In the context of Z, the solution is A3. So we're talking about a cognitive system having the ability to rationalize and give options for a human to choose from, right? At the end of the day, a system might take one decision like an AI system would take, but here the doctors are given the importance to take the final call and take the solution forward, right? So this exactly is nothing but the human interaction based AI or human aware AI that I was talking about a minute ago, right? So this is very quickly on terminology. So now we're actually moving from learning to intelligence, right? So people were talking about learning strategies earlier, machine learning, which included things like deep learning methods, session tree based learning, or Bayesian learning, or kernel based learning, or association based learning. The focus initially when machine learning came into light was more on how do we ensure machine learns, right? Now, definitely things have gone beyond learning. We're talking about intelligence, right? Intelligence is an outcome of a machine learning, right? And the machine has learned something, it exhibits intelligence, it gives conclusions or it gives options for humans to take it forward. So the focus is primarily on intelligence. Now that brings us to what intelligence means, right? There are multiple levels of intelligences, right? If you look at it, when you look at a just born baby or a toddler, right? A toddler can recognize a dog. Let's assume we show a pup or a dog to a toddler. He easily recognizes. How does he do it? He recognizes because a dog barks, and a bark could mean, something like a bow. Bow could mean a dog for a baby, right? So that's how they recognize. So how does that come? So this learning happens naturally to we humans. We call that perceptual or manipulation intelligence, right? This comes very naturally to us. Today, if you look at all the captchas designed for catching robots red-handed, they're all defined based on this perceptual intelligence. Then the next level is the emotional intelligence. We're talking about the emotions that are played and how does this influence decision making of a human, right? So, and next you've got social intelligence. Then you've got cognitive and reasoning tasks or intelligence on that front. So if you look at it, we humans grow from having perceptual intelligence to cognitive and reasoning intelligence, right? So we all end up writing our JE or entrances, the SATs. All of us, we build cognition as a part of our intelligence when we grow up. But it's other way around with the machines, right? Machines start with cognition, and now they're moving towards perception and manipulation intelligence, right? So that is the relationship between the intelligence between this. Now, a very quick note on what's the difference between a human and a machine intelligence, right? Humans perceive by patterns, whereas machines perceive by rules and data you provide. One of the biggest difference. Then humans, they store recall based on patterns. For example, I would remember a mobile number based on a pattern, that it gives me, or maybe I link it back to somebody else's birthday or an anniversary, and I try to form a pattern and remember that or store that. But what machines do is not that, right? Machines actually use searching algorithms, which are very deep and complex, and that's how they remember and store. Then we humans can figure out the complete object even if a part is missing, right? Let's say a tail of a dog is shown, we can recognize, but machine does require the overall picture. It does assessment to multiple levels, right? So this is a very basic difference between these two. Now let's understand what an intelligent system is, right? So an intelligent system is multiple things. So it's beyond, we're talking things beyond machine learning now. So we're talking about these systems acting and thinking like humans and rationally, right? Let's take this example. A system that acts like a human is nothing but something that is better done by humans today, rather, but a system that takes actions and executes, right? And a system that rationally thinks is something that emulates intelligence, right? Today we are able to do that. We are able to give more data to our systems, and we are able to emulate intelligence in the systems, right? Then we're talking about systems that think like humans. That means literally in sense of how our mind works. So neural networks, multiple things which have come up, they are more like thinking like the humans are thinking. And rationally, now this exactly is the computational study, and this exactly is the cognitive computing that I just mentioned. So this is a very interesting view of what intelligent system means. So at the end of the day, an AI includes philosophy, mathematics, computational linguistics, cognitive psychology, computing engineering. It's a combination of multiple things, right? So if you look at most of the projects we have, engineers are deployed only 10 to 15%. You know, it's more of sociologists, psychologists who are working on these projects more than engineers, right? So that's what it is. Now let's look at different categories of AI, right? So you've got artificial narrow intelligence, then artificial general intelligence, and we've got artificial super intelligence, right? So there's a very interesting analogy out there that you can see on the slides. We're comparing this with Terminator movie characters, right? So artificial narrow intelligence, you can map it back to the killer drones. It's like what you see is what you get, right? So you give A and then he gives back B. It's a straightforward narrow intelligence. Artificial general intelligence is Terminator himself, right? So he understands many things and tries to act like human. But the Skynet character of Terminator movie actually is artificial super intelligence. That is where we've got new tech stacks coming up, the Google APIs. So you can think of narrow intelligence being Google SEO, the earlier part of Google, which is research, and then we can think about autonomous cars, self-driving cars as artificial general intelligence. But Google, which is running now, is potentially even an artificial super intelligence, according to the definitions, right? So it's about capability which goes from one level to including intuitions and ambiguities. That's what cognitive computing is all about. Next, where do we use artificial intelligence? So I'm going to spend about 10 more minutes giving you some of the real world use cases and some of the robotic automation use cases that are existing. And so if you look at this diagram, artificial intelligence is used in multiple cases. One is expert systems. I gave you an example of what expert systems are. Neural networks, I'll just speak about that. Robotics, I'll talk about what automation is, what is robotic automation, what is RPA, what is IA. I'll just very quickly touch upon the automation areas and what market is looking at from these. Natural language processing and of course fuzzy logic. All of us are aware of this fuzzy logic, right? So this is a very quick slide on each of these areas. So we are talking about flight tracking systems, clinical systems. Expert systems are those systems which can understand data at the next level, can take decisions, move forward and run with them, right? So they are the expert systems. So autopilot modes, flight trackers, all of them come under that. Now, natural language processing, I think today, all of us, while I'm speaking to you, all of us today are using this, right? So we've got speech recognition, all those who have Apple phones, who use Siri, or all those who've got automatic voice inputs in Androids or something, or all those people who are using social media and trying to, and applications which help to understand what we know, what we don't know, right? So we're talking about those systems. So everything, let's take an example of Google search, that is NLP again, right? Natural language processing. Understanding what you're trying to search, ranking it, and getting the right results is all about that, right? Now, neural networks is a very interesting field, right? So it's a very deep one. I'm definitely not looking at covering this, and completing it in the session, but I want to give you a series of blogs, links to a series of blogs, and a bunch of GitHub links where I've got TensorFlow based code that's implemented, up and running. You can download, follow the instructions, and implement. So today I'll just walk you through those, and you can do. Neural networks is primarily a pattern recognition mechanism, right? So for example, if I give it an image as an input to a neural network system, it works in multiple layers. So they've got hidden layers, they've got input layers, they've got output layers. That image is understood in multiple layers, and then finally the output of, it could be thousands of layers, the feedback goes in from one layer to another and propagated back as an input to the forward layers, right? So most of you, if you are in the session, I'm sure you must have at least Googled about this, and so we're talking about multi-layer based deep learning, right? As one of these, and a lot of examples, your handwriting recognition, image recognition, object recognition, all come under these things. Now, definitely robotics, we're talking about the super robots, the robotic process, the bots as a part of the RPA. Everything is part of this. Now, we're talking about these robots having the ability to sit in front of humans, understand human expression, take inputs, and then take an action, right? So today we've gone to that extent as a part of human interaction and aware AI. Then definitely fuzzy logic. I don't think I really need to cover much about this. We're talking about the general rule-based machines that operate. So it's like you set some temperature in your air conditioner, and then after the outside temperature comes to that, it automatically sets itself. That comes as a part of your fuzzy logic too, right? So now this is an interesting slide. So what kind of tasks that does AI solve? You've got expert tasks, you've got mundane tasks, you've got formal tasks, right? The expert tasks definitely are categorized under engineering tasks, scientific analysis, and medical diagnostics, where deeper learning is required and understanding of the symptoms is required and suggestions is required. So that's expert tasks all about. Then mundane tasks, general reasoning. We're talking about general reasoning. Typically your sentimental analysis, or Twitter analysis, all that you see, they come under these, which requires human reasoning, NLP, the perception management, the common sense, all these come under these. The formal tasks are the gaming apps, right? So the way we build, intelligent systems to understand the tricks of the game by giving data, and the math involved behind this is all about formal tasks. So for each of these task categories, we have got different way of implementation, different algorithms which run behind. So I will spend exactly a few minutes on the levels of automation, right? So now this is a very interesting slide because I did speak about, artificial intelligence is now, humans are really fearing artificial intelligence, and they fear that they'll take over humans. But at the end of the day, if you look at it, the way automation is categorized in the slide, it's very important. Depending on the use case, you choose what level of automation you need. See, I work for a banking and financial services industry, and our regulatory compliance is very, very important for us. We cannot let a machine do an end-to-end activity, right? So what we do is, we've got manual controls like 4i verifications, workflows, wherever required, where a human has to come in and press that red button for the next level of operations to go forward, right? Let's look at these categories. What kind of automation AI can help, right? The first is no automation. We're talking about a case where the machine does not provide decisions or does not take actions, right? To that, we're talking about machine that provides all decisions and can take all actions, right? The third level is we're talking about machines which narrow down selections based on a few options. So I was talking about cognitive computing case where we're saying that it takes care of understanding a lot of context, and then it says what works, what doesn't work, right? And the next case is a process runs, it allows humans to give their input for a certain period of time. If they don't give any input, it proceeds, right? So that's, part automation kind of a thing. Then execution only when human approves. So it has identified some recommendations, the machine, but it will execute only if I press the red button, right? That means humans have complete control over it. And we're talking about cases where machines just give one alternative solution. They say this is the best to go, but alternatively you can do B, right? And executes automatically, then informs humans, right? It does everything and then say FYI, right? We can take these in cases where it's not a mission critical thing where a company would incur losses or there's no compliance issue where the decision is taken, the calculation is done, the action is taken, but it says, you know what, this problem came, I solved it this way, what do you think? Or you want to know, kind of a thing. So another case is you inform the human only when they ask. Another case, you inform the human only when the computer decides. You can code all of these as rules, right? So that's what I was talking about. Then computer decides everything, executes everything, ignoring human. That's an ultimate state of automation, right? So AI algorithms can be used to achieve any level of automation in the pipe that you're seeing out here, right? Now let's look at it, what cognitive automation is. We've moved from simple automation script to RPA, where we spoke about taking structured data, coding the rules, and executing and seeing how it runs, to introducing a bit of automation in terms of workflow, identifying unstructured data, handling complex rules, to bringing in cognition with AI, link it with AI, and take the intelligence derived. Let's say I've got 10 robots, bots working on a process. Depending on how they operate, the output comes. You've got a system recommending on potentially how better a bot can be configured for execution, right? So this is the evolution of automation, and all of you guys should watch out for intelligent automation systems, robotic process automation systems, where AI is deployed heavily, right? That's about AI, ML, cognitive, that brings us to an end to introduction to AI, and I hope I managed to cover a bit of information on what AI is all about. Before we move to deep learning, what we do is let me go to my GitHub link, right? What I would suggest all of you is you subscribe to my GitHub link. I've got a lot of machine learning algorithms which I opened up for free access today, right? So you can find them in Python, R, Spark, Mahout, Julia. I've got about almost 200 odd pieces of code which are ready to run for you guys, right? I'll be blogging about this in a bit, so you can actually look at a few algorithms that have been given, which includes things like artificial neural networks, deep learning with the data, right? And using perceptrons implementation and many more things. So these are available for your access. Feel free to download them, access them, contribute back to them, right? So you guys can use it and give feedback directly back to me for improvising this. What I'm going to do is I'm going to create a separate folder for TensorFlow, and then you guys, all of you, can get access to that, download and use it very well. Okay, so this is you can search for the name Sunila Gollapudi and you can find this, and it's open to all of you, right? So let's start with TensorFlow. So I am assuming in the room I've got people who have hands-on knowledge versus who are curious about knowing what it is, versus who know some basics but looking forward for what to expect from it. and things like that. So very quickly, there are many deep learning libraries. TensorFlow is one of them. Most of the things which are listed out here are open source. So CNTK by Microsoft, Torch, then Caffe, Theano, TensorFlow, many of these. So today what we'll do is we will go through TensorFlow, its syntax, what are the important pieces. And I'm going to share with you all a bunch of links that you can access, download the code, try your hands on, starting from installation to running it completely, right? So I'm going to do that. Okay, so let's go to the next one. I'm trying to open, let me get this completely out here. In case I have any questions, I just want to ensure I'm seeing the questions. Just give me a minute, I'm just opening this up. Your voice is breaking, it's not clear. Can we get the slides, but you're not the webinar? Yes, of course I can share all these things. How to choose which deep learning library to use. Right. So I'm going to definitely get back to you with more details on this choice. There are a bunch of blogs that I want to share with you, a bunch of 6 blogs that you can go through, right? So, right. So is IoT related to this? Deepak, right? So I'll take a few quick questions which are, interesting, and I move forward. So IoT is related in the sense how. So if you look at it, today when we're talking about intelligence, machine learning, at some point in time we were talking about, it's no more a time where we're generating, giving general intelligence to or insights to the world, right? It's all digital today. That means personalized feedback, personalized recommendations needs to be given. Let's take a simple example. If I'm a South Indian, I like to eat curd rice. Let's assume I've got social media or a machine learning algorithm which is looking at me, and based on where I am, it's trying to tell me which is the nearest South Indian restaurant and where I can get the best curd rice, right? So that is the kind of insights that people are looking for. I mean, applications or end users are looking for. It's no more general set of bunch of recommendations that they're getting. So IoT plays a bigger role out here because we're talking about the data burst which is coming in and how that can be taken as an input. So if you look at it gradually, when we started understanding algorithms, we said, oh, the algorithms are intelligent, we can use these algorithms, we can model them, take samples of data, execute them, run them, and see how insights have come. Oh wow, the insights look interesting, how do you use them? Later things came up where we said, you cannot do things in batch, you will do in real time, right? So the need for taking data in real time and running these models has become paramount. Right. Later, another level of advancement happened where they said the data that's been given is not just in one format; it's in multiple formats. It is free flow. It is digital. It is unstructured, and it is really large in volume with 50. And finally, it came down to saying, okay, we've taken all this, but now your recommendations cannot be for a clan of people. All women like pink color is not accepted anymore. Right? So everybody is looking at specialized personalized recommendations. That's where IoT comes into picture, right? So there are a few more questions I'll pick up. Once I give a very quick overview, I'll do this itself. Can I use TensorFlow in self-learning AI? I would suggest TensorFlow is only a part or facilitated to AI. AI is much bigger a field. You should learn AI in terms of algorithms, languages. I spoke about a few things today. So I'll share more material with you on the blogs that you can follow. But I think you should really focus on learning the concept of AI and then using TensorFlow to implement it. That's what I would suggest. Please provide the link to your GitHub. Yes, I'm going to post it to you on the blog. Can you transfer learn on reinforcement learning? Right. What exactly is reinforcement learning, right? Reinforcement learning is one of the learning mechanisms where we're saying that the input to the learning algorithm is given by a positive output to the same algorithm, right? So as such, TensorFlow does have libraries for that, right? It also has got libraries for AI as well, so it can be used technically, yes, right? So I think I have answered a few questions, but I'm going to definitely take these questions at the end. I know good questions are coming up. Is Python important? Yes, Python is very important. I would recommend anybody who is looking at being a data engineer or data analyst to be a Python expert and not an R. R is used for initial experimenting, but anything you want to productionize, Python is the way to go. And if you look at it, most of these libraries that I'm speaking about also have Python as the base, right? So I'll stop taking questions here. What I'll do is I'll very quickly spend some time on TensorFlow, how the library works, what the syntax is, and I'll again get back to you on the questions and we can take it forward. So what's TensorFlow? TensorFlow actually is an open source library that internally uses Python, and it uses a concept of data flow graphs. So I'm going to explain what those data flow graphs are, right? And how is it different from the usual machine learning algorithms, right? I'm sorry, there's a small mistake in this slide. The latest version of TensorFlow is not 1.2, it's 1.3. My bad. Please consider this a correction. So it was originally built by Google, and then it was actually moved towards machine learning and deep learning kind of a thing, right? So it is, by the way, it's not just for deep learning. Like one of you asked out here, it's got algorithms for non-deep learning cases too. General machine learning, supervised, unsupervised, reinforcement, unsupervised learning algorithms as well. So you can have a look at that, right? Definitely use it. So this is the background. Now it's one of the most popular Python-based open source machine learning scalable framework, right? One of the reasons it's famous is part one, it's based on you've got Python, it's very easy to move. Part two is if you've got large scalability requirements like running on GPU and CPU based on configuration changes, it works fabulous. So I've got a bunch of algorithms which I built on TensorFlow with all the comments in the code. You can just download and use it as well, right? Let's look at this. So the core architecture of TensorFlow, the core is C++. It being a C++, helps it to be scaling well. So it's got both C++ frontend and Python frontend. Python is definitely the maximum and most adopted till date. So if you look at it, at the end of it, there's a core framework that TensorFlow has, which can work on CPUs and GPUs or any other infrastructure systems, right? So can Java be used? No, Java cannot be used. Either it's Python or C++, and Python libraries very well work with them. So I'll give you a bunch of code pieces also on that. Somebody is asking, can I build an intelligence system from scratch with the help of any of these platforms, such as TensorFlow? Are there any useful tutorials as well to get hands-on feeling? Yes, definitely. You can start with TensorFlow directly, right? And what I'm going to do is the next 6 blogs, I'm going to post them on HackerEarth blogs itself for all of you to follow, which will be an extension to today's session. And I'll appreciate if you all can follow that. I'll share my cheat links and all out there as well. So I think you should start with TensorFlow, start with Python, and then do it. Right. So the next one. I want to very quickly make you understand the difference between GPU and CPU. I'm sorry for the guys who already know about this, but I thought it would be a good idea to introduce this concept. So CPU, you all know, we all developers know it. We're talking about a bunch of multiple cores the application is built on. But a GPU is multiple CPUs, right? It's thousands of cores in it, right? That's exactly how it helps parallel workloads, efficiency, running it parallelly. So conceptually, GPUs are a superset and can hold multiple CPUs, right? And I've given a small piece of code here, right? So the way TensorFlow works is TensorFlow has got two concepts. There are tensors and there are sessions, right? I'll tell you what these tensors are. Tensors are nothing but multi-dimension arrays. Let's say today you're talking about R and you're taking a data in an array or a frame, right? So that's one dimension, it can be two dimensions. But when we talk about tensors, these are specifically multi-dimensions, right? What do you mean by multi-dimensions? What do they store? I want to give you some more information about that. But just have a very quick look at this. The best part about TensorFlow is you can configure the device on which it would be running, right? So you would like to run it on a GPU, you would like to run it on a CPU. That's a code-based, right? So somebody who's got basic knowledge of Python will be able to understand the syntax you see out there, what I'm showing you on my screen. You would be able to understand what that's all about, right? Let me just give you, you've understood, right? You can add multiple GPUs, you can add multiple CPUs. CPU 0 would be current machine. CPU 1 cannot be used, but in case of GPU, if you can use multiple, you can give the details of the extended GPU as well. That's how it scales very well. Now, what exactly is a tensor? Now, this is a very simple slide which I again flipped from the market. Let's look at that, right? So you've got a tensor can have multiple modes, multiple dimensions, a dimension within a dimension, right? The moment you're able to hold data with these multiple dimensions, and you can have your algorithms run on these multiple dimensions, that's where the entire power of parallel processing, handling multiple dimensions and the complexity comes in, right? If you look at the example of one dimension, we call it matrix. Two dimension, we call it, one dimension we call it vector. Two dimension, we call it matrix. Three dimension, we call it as 3D array. And you've got n dimensions, right? So this is exactly the syntax of how we could actually import a TensorFlow library and initiate, add, and do some basic operations, right? So this is for just a flavor of how the programming languages looks to you. Let's take an example of TensorFlow graph in a much more smaller text, right? So you've got user feeds, which are inputs from here. The W that you're seeing out here and B that you're seeing out here are actually inputs that come from the algorithm which has already learned it, right? So that's what it's all about. That's what it says. And then you give it to another function which adds, and the ReLU actually here is an optimization algorithm. So you've got this complete flow, which has got multiple operations happening. Layer 1 does math multiplication, layer 2 does addition, and layer 3 does optimization, right? So this is a very simple graph that you can see. So I've given code pieces for these in the GitHub too, that you can all have a look at, right? This is definitely to get you again acquainted with how to define variables, what are global variables, how to define a session, how do you run a tensor once you create out of it, right? So creating a vector, creating a matrix, creating a scalar object, how do you do that? And then initialize these objects, and how do you run the session? So this is one of the samples I have. There are some visual tools available in the market for TensorBoard. You can try this. So I'll give you much more details on the blog on running these two, right? So you can have a look at this. Definitely, now we've actually covered a bit in terms of how the flexibility can happen, right? So let's take an example, right? So we've got data, then we've got a learning algorithm, we've got multiple models which run one after the other, right? So we can pipeline these in the tensor graph. We can run them one after the other, And then we can scale it on a GPU as well. And all of them, the best part about TensorFlow is they're available as APIs. And they're all available on my JIT. Again, you can have a look at that. And you can just invoke an autoencoder or a perceptron code and have a look at it on how to invoke it as well, right? So very quickly, I'm going to summarize this and take all the questions from the audience and cover some of them. Very importantly, 4 steps, right? You've got inputs and outputs, you have placeholders. So when you're doing a TensorFlow code, I have told you that you can do a Docker-based download in Windows or anything. I'll give you a couple of instructions on the blog that you can follow and do it. So you do an input-output definition declaration. You define the weights. The weights are nothing but prioritization of the attributes, right? So which dimension would mean what priority to this? You define the inference model. We're talking about running a machine learning algorithms, which could be a deep learning algorithm like an RBN, or which could be autoencoders or any other supervised, unsupervised machine learning algorithms as well. And then we have got optimizers and loss functions that we do to look at the accuracy and optimize the complete model. Then step 2, we train the model. We overall optimize again using values and logics, and I've taken some examples. And then you publish this model, right? So it's as simple as these 4 steps. So 3 things I promise the group in the room is access to my JIT completely, and a bunch of blogs that I will coordinate with HackerEarth team to get them published, which will talk about starting from installation of TensorFlow for Windows and Linux and iOS with Docker or with IPython, right? And using Anaconda or multiple things, and give you 18 algorithms, right? With data sets, which you can download and execute them from scratch, right? So these two, 3 things are promised from my side. And it's a very straightforward thing. I'm assuming I have given enough inputs for the group online to take away, understand, or people who are looking for basics and got information for TensorFlow and AI as well. So what I'll do is I'll probably very quickly take a few questions right out here. Quite a lot of questions have been posted. So I will take a few of them and answer them. Let's do from the bottom. So the guys who asked last are the best. Right. Hi, from where can I start doing deep learning projects? Are there any hardware requirements to implement deep learning algorithms? I've got 4 GB RAM, is it enough? Typically, to run a deep learning algorithm, Subhajit, you will not need a bigger system. The problem comes with data, right? The moment you have got bigger data, you definitely need much more storage. My laptop, where I run most of them, I managed to do with 16 GB RAM, but please ensure nothing else is open on your laptop or your system when you run these, right? So you can start directly with TensorFlow things. I would suggest in terms of projects and use cases, so Sujit, please start with image recognition, voice recognition, natural language processing. So you take a bunch of mails, take the data from it, run NLP algorithms, and see what kind of insights you can derive, what kind of categorization you can do of them. Basic things like doing even spam things can be done using NLPs. So you can start with basic things. You can give a bunch of photographs, right? Feed it to a system, and then generally see how the algorithm picks up and predicts, identifies a specific face in an image. They can be very basic things. You can start with that. So which then TensorFlow is definitely a good place to start because it's got a lot of out-of-box things. But if you want to run with large data, please ensure you have a bigger server. But 8 GB to 16 GB, you should be able to start with. That's all I can say. Can I work upon cryptography and AI? So I'm not sure what the question is, Mamta. So cryptography, to solve cryptography problems or requirements you want to use AI? Does it mean that? Are they related? See, cryptography is all about security, right? How you mask data and store it, right? If you're talking about relation, to be honest, technically they're not related, but if you like to use AI to identify what kind of cryptography should be done, right? That could be a case. But cryptography internally uses AI, I'm not sure about that. And they're not, can we install TensorFlow in our studio? No. TensorFlow works with Python or C++. The guys who are learning R, please ensure you all learn Python well for you to learn this. And then the other question I got is, what are some of intermediate problems? One second, I'm just losing all the questions out here. So, can I work upon cryptography? Are they related? Yes, I got this question. As in TensorFlow, a neural network is created. So, in case of supervised learning or algo like classification regression to predict some results, is there also that's a big question. Is there also creation of neural nets behind the scene? So we use neural network based algorithms like ANNs, RBNs specifically for neural network based algorithms to be kicked off, right? So if you're using a regular regression, not essentially, not necessarily. Can we apply MLDL to a particular type of problem like image processing? Of course, Rishikesh. That's one of the problem areas that is used by deep learning algorithms, right, and AI algorithms. Next, I have answered this question. What are some of the intermediate problems in ML? Can you suggest some good projects in ML and not in deep learning? Thank you. Anirudh. Suggestion of good problems in machine learning. Let me tell you, I might be sounding a little stupid and dumb out here, but in my opinion, any application which is rule-based can have potential for machine learning to be applied, right? Any application which is rule-based, right? You're talking about workflow rules, assignments, or whatever. The workflow rules can be automated by machine learning or AI, right? That you can take that as a thumb rule. In my firm, a lot of margin logic, netting logic, which are business rule based, are all eligible to be picked up, right? By this. I'm a beginner at machine learning and I want to do a project that any possible suggestions. Unnimaya, right? Unnimaya, you can actually look at Kaggle, right? Kaggle is one of the places where they publish open projects. But unfortunately, Kaggle isn't great if you're looking at end-to-end experience because they give you clean data most of the time. You don't get an opportunity to clean the data and run it. So if you want to be really expert, then Kaggle is the place. But if you want to start learning, definitely Kaggle.com is a place. Please go ahead and register yourself and then do it. I'm using Keras on top of TensorFlow. How should I decide how many layers I need to add on in a sequential model? Aman, superb. See, Keras is one of the best Python layers that works with TensorFlow. That's a good choice. May I know which algorithm you're looking at running? Neural net? What's that, Aman? If you can answer, I can let you know. And the problem that you're looking at solving as well. I'll definitely get you the answer. Aman, neural net, linear regression. Perfect. So when we're talking about multiple layers, right, Aman, the way it works is we start with a basic assumption of layers, right? The hidden layers we're talking about. How can I ask? Okay, Teruku. Okay, I'll get back to you, Shriyashta. Let me answer Aman. So, Aman, typically when we're talking about neural nets, right? So depending on the kind of problem you're solving, we choose, and the choice of number of layers also, we need to start with trial and error, right? A minimum layers for a neural net that I've tried is 30 plus, right? And based on that, I incrementally increased by tens, right? The hidden layers, right? A number of it, that's what I was talking about. So Anand, I'm answering the same question on how do you decide number of hidden layers. So on an average, when you choose a problem like an image recognition or handwriting recognition issues, a basic configuration goes from 20 to 30 layers. In fact, you're not at loss, because even if you choose more, it will only be more accurate, because even the layers would run in parallel, and the efficiency is high. That's what it is. Then that's 5 only. you should try with more, Aman. You should try with more. And if you look at the basic configuration, 20 and 30 is a good part of it. Okay, I'll go for some questions above, because a lot of people have asked. What I'll do is I'll take 10 minutes to answer, but my coordinates are available on my LinkedIn profile, and they're all available with HackerEarth. You can connect with me for any further questions. I'll be really happy to answer your questions. What are the prerequisites for TensorFlow, and where will you find the GitHub for your project? Prerequisite for TensorFlow, I would suggest a basic understanding of AI deep learning algorithms is a must, right? And then you have to know Python well, right? At least understand the script. So Sirish Sinha, that's what it is. Let me try a few more questions. So low ahead, can you explain what low overhead? Also about training the AI and GPUs and the cloud. Okay, so Mamta has a question for me. Training the AI on GPUs and cloud. Right. So right now TensorFlow works pretty well on the cloud AWS. I've got one instance that I have spun off on the AWS. I can share the configurations for those and how the API is invoked. Definitely is cloud compatible. A lot of data that that is large in volume, you can run it from there. And your GPU question, I did answer. So TensorFlow has got a mechanism where in the code itself, I can configure, GPU on the same system or across the systems, right? So, Manta, you can do that. Cloud, definitely AWS got connectivities, which I'll share with you again. You can run, I'm running on the AWS right now. So you can have the code from me. Is it possible for someone to implement machine learning technique, say using specifically from TensorFlow, without actually understanding underlying code or algo? Absolutely, Karthik. You don't have to know how an algorithm internally works, but you should know what is algorithm, what problem it solves, and what kind of attributes can be passed. So when it comes to any machine learning language, it's not just with deep learning, right? Any machine learning algorithm, all you've got to know is how an algorithm works, right? And what context. Let's say if the attributes are ordinal, it's a combination of cardinal, ordinal, then this particular algorithm can work. Or if I'm looking at classifiers where I don't know the boundaries, and clustering can be used. As long as you know what algorithms are existing, which algorithm can be used for what, you don't have to understand and write the algorithm down. Right? So Karthik, you can be rest assured. And with all these new APIs coming up, you've got multiple, multiple open source APIs which are very simple, right? Let's go for more. So where can I learn AI from scratch? So AI from scratch, there are multiple tutorials available. So basically, I'm doing a bunch of videos and blogs that I'll share with you guys in the next few weeks. But I would suggest you all enroll yourself to Symposium, the Triple AI Symposium, right? If you go to triple-ai.org, the India chapter opened a few weeks ago, and that's open in Hyderabad out here. And I stay in Hyderabad. And in fact, you can get access to a lot of AI material once you take a membership, right? You get access to the forward-looking 4 or 5 years down the line, how system, AI is going to look, many more things on those fronts. You can get connected to the experts, PhDs, and what they're doing. I would suggest learning about AI. It would be very nice if you could attach Ramesh yourself to open source forums like AAAI.org. Now for 1 year, the membership fee is only 1,300 rupees, Indian rupees. So I would suggest you please go and grab the offer, otherwise you have to pay a lot of money, right? Yeah, it is. Shruti, the compatibility is on for Python. Shirish, no Java, please. It's Python, C++ for TensorFlow. System, okay, I've answered this question. How is machine learning algorithm for robotic compared to obstacle avoidance algorithm? Could you please? Systems response. Chris Matthews. Okay, how is machine learning algorithm for robotic compared to? Right, when we're talking about, Chris, when we're talking about robotics, right, there are two parts to it. One is we're talking about physical heavy lifting, moving robots which behave, think like humans and do, and we're talking about software robots which are called bots, right? The bots are nothing but your software systems which sit on your laptop or your system and automate it, right? So obstacle avoidance algorithm, I'm not sure about what you're referring to actually. So machine learning algorithms for robotic typically are the AI algorithms, the neural nets are coming under that, and the human interaction, AI is also coming up and the interaction is going on, and software bots can work on general machine learning as well. I'm not sure if you're happy with my answer, but I'd love to connect with you offline to understand this more, Chris. Whether TFLearn and TensorFlow, TensorFlow are same. No, there's a difference. And I'll give you in my links on what differences. My code uses both of them, okay? And you can use them as independent libraries too. Gaurav, you can use it. Can I use TF in self-learning AI? Of course, yes. The entire algorithm bunch that's available out there can be straight used. How to choose which deep learning libraries to use? That's very use case specific. In the beginning of these slides, Aman, I have actually given you a difference between what kind of tasks are existing, right? Expert tasks, then mundane tasks, then daily tasks, right? So different algorithms categorized into those. Even those I can share with you. So anything that requires human kind of rationalization, you have to go with neural nets and deep learning methods like RBNs and autoencoders and perceptrons and things like that. Okay, the initial people were complaining about my voice. Hopefully it was fine. After that, I had hear it later. How weakness can start a career in AI. Presenter's voice is not clear. Okay, so I think the initial ones has been yes, good. Thank you, welcome. Okay, so what we can do is, how is ML algorithm different from the traditional algorithms used in robotics? Chris. So machine learning, see, any algorithm used in robotics is a machine learning algorithms. We are letting the machine learn. So anything which you're coding with rules, Chris, is a rule-based system which is non-algorithmic. So, but robots are all built on machine learning algorithms. None of them are built on general algorithms. There's no general algorithm out there. So data is provided, the machine learns and then performs and shows intelligence. Where are you people asking questions? Teruku, Sriharsha, you can post your questions in the same place where you're writing this point. And I'll answer. All the questions are in the same place. Can you provide any material links? That's my promise to you, Sandeep. I'm going to do that definitely. Ramesh Krishnan Mohan, I'm Scala developer. I found Scala module. I actually import Python module into Scala. TensorFlow also can import into Scala. Does it reflect? Okay, Scala, yes, it can be used, but it's very, very preliminary, Ramesh. So if you look at it, Scala with Spark, with Python, I try to experiment a bit with that, with Spark. But it looks very rudimentary to start with. I would suggest you explore TensorFlow separately, Ramesh, and then get into trying with Scala. Can you suggest some books for AI and deep learning? Sure, I'll mail you back on that. Sheesh. It's compulsory to be good with programming skills like programmers who code for ML. Now, Pranjal, that's a good question you raised. It depends on what kind of role you're playing. If you're going to be on the ground building machine learning algorithms, being a data analyst or engineer, right, you have to be good with at least one scripting language and preferably Python, right? If you're going to be primarily on the domain side of the data science, where you're translating the results and giving the user domain-specific language, then R should be good enough for you. You don't have to be good with programming. You should know what algorithms exist, how do they work, and things like that. In fact, I think I can share this with you. If you all can see my screen, I've got a complete map of all my algorithms and what are the categories and how do they work. So I'll share this image version of the map on the, the blog as well, right? So if you look at it, I've got all these learning mechanisms, tech stacks, right? What work under which learning technique, what works under deep learning, what works under reinforcement learning. I'll share this with you. This can give you a one-shot view of what's happening everywhere, and then you can go back and drill down into, whatever you want to look. It's of course courses on these. I'll share them with you. So I guess I have managed to answer quite a lot of questions in the room. So you all can connect with me on this email ID. This is my official email ID, right? That I posted out there. And then you can look up on LinkedIn with me for Sunila Gollapudi. And HackerEarth blog, I'll work with Rashmi, Vishal, and the organizers to get some material out for you. And some of these which I'm showing you on my screen, and post them back to you for usage. Hope you all enjoyed this session. This was definitely, what's your LinkedIn ID? It is Sunila Gollapudi. You can search with Sunila space Gollapudi. And my email ID is sunila.gollapudi@broadridge.com. That's a firm I work for. I'm not able to see the comments. Yes. I shared this with you out there, but even Vishal and HackerEarth guys can share my coordinates with you. Thank you so much. It was a pleasure presenting it to all of you. Thanks for your patience and listening to me.